we'll start at 12:05. Just waiting for others to join. And yeah, just let one person be recording this one. So if like Rambana, I can see has started recording, so let him handle this recording. Okay, before we start, so today's session, I think shared the details. It's more about version control system, and it's one of the tool which we are going to discuss about today is Git. Okay, so how do you want to proceed? Do you want to make it as interactive session, or we should go ahead with like I'll give the basics first, and then we'll take the questions in the last. Any suggestions?
I think the second option will be a better one because many of the people here maybe they are not aware of this thing.
Sorry, your voice is breaking. So let's go. Let's get started with the fundamentals of version control system, and then we'll move on to the questions, and we'll do some practicals as well today if time permits. Okay. So I'm sharing my screen. Let me know if it is visible. Is it visible to all?
Yes,
Yeah,
yes,
it is.
yes.
So we'll talk about version control system today. So like what is version control system, why we need, okay? Before getting into more details, like what is version control system and all, so we'll understand like why we need the version control system. And then we'll talk about the different types of version control system. Yeah, sorry to interrupt. Whomsoever is not speaking, please go on mute.
Hello.
Yeah. Yes.
Hello.
Yeah.
Uh, uh, just one thing. Your voice is little low. Probably, if I'm the only one who is doing it, or probably, or it's fine with everyone. Not sure.
Okay. I'm just using the headphone. Let me try. Is it working fine now?
I'm not sure, but rest can probably confirm, like if they are able to hear me.
Yes, for me it's
You
working.
you yes, Devraj. Uh,
Yeah.
you joined from mobile or laptop?
Okay.
If you joined from mobile, then turn on that speaker.
Okay. Okay. That's fine. Continue.
Okay. I believe it's all good for everyone, right? So expect Devraj. So yeah, let him sort out the issue, and we'll start. Okay. So today's discussion about a version control system. So what is the need of version control system? What type of version control system we have, and how like then we'll talk about Git and what are the different parameters of Git, what are the different components of Git we can use. Okay. So just a recap on the last session which we have done on DevOps fundamentals. So we heard about uh, like continuous integration, continuous delivery. So that continuous integration, we talked about like multiple developers working together, checking out their code, checking their code, and the build happening for every check-in. So as part of that continuous integration process, we are on the very first stage where we will talk about the version control system. So what is the need of version control system? So why we need is, first of all, the versions are needed for recovery. So for example, even if you're working on any of your file or any of your presentation, say for example, I'm working on this presentation, okay? I was writing something and somehow someone has deleted it, or somehow I did some mistake, okay? And or somebody, like I have 100 slides, I don't know who changed what, and somehow like it stopped working. Okay, so what I can do is, like if I different copies of this particular PPT, so the very first thing what we see in, like if you are from system administration background, if you change something, take a backup first. So whatever file you change, before changing it, even in dev system or specifically in live system, what you do is you take the backup of that file first and then make the changes in that file so that you have a previous version to restore. So if something goes wrong, you take the previous version. What if like multiple people in your team working together and they have all the same skills and they're all working on the server and they're changing simultaneously? Okay, sometimes like one person is changing, then another person comes in the shift, he's changing. So something is broken and you don't know like who has broken it. So it's very hard to track. So what if like, every person who's doing the changes take a copy of the uh, previous state? So like you'll have different versions of the previous state. So now you know like which one has worked and you can easily restore. That is manual restoring. The same approach we use, it's been used in some tools. So that is basically version control system, where you can have multiple versions of a file so that like it's very easy to restore. Multiple people can work together for the integration. So any doubt on this?
No, sir.
Okay. Okay. Now we'll move on to the different types of version control system. So we have centralized version control system and we have distributed version control system. What is centralized control system? So centralized control system is something like all your repository resides on your central server and you only work on specific files. Okay. So for example, you can see like there is a file. Okay. Yeah. There is a file which has multiple version 2 and 3. So you like computer A will check out the file, computer B will check out another file. They start working on those files and they make their changes and push it back to the server. So what is the difference? Yeah, we'll talk about difference later. So this is what is your central version control system. So where you have to be connected with the central hosting server all the time whenever you want to communicate. So what communication happens? One is like for check-in, check-out, that connection is needed. For adding and or doing the commits, the connection is needed. So for every time you need to be connected with all the operations, you need to be connected with central version control system. Okay. What else? It is a single point of failure. So all your information, all your repository, all your code resides on the central server. If the central server goes down, then everything goes down. So that's one of the drawback. So this is one of the version control system being used in 20th century. In 21st century, we use a distributed control system. So the example, if somebody asks about example of centralized a version control system, it is like SVN. You must have heard about SVN, Tortoise SVN or something like that. Okay. We'll move on to distributed version control system. What is distributed version control system? It's as good as centralized version control system. So the server is having all the details, all the versions of your files, your code, everything. So the only difference is every local computer will be having the same copy of the repository. So in SVN, what we do, we work on files. We we are not working on the whole repository. So you check out a particular file, you can check that version. Even if you want to check the version history of that file, you have to go and communicate with the server. But in a distributed version control system, you have the whole copy of the repository in your local, and you can see all the information related to version, commits, and even like if the server goes down, okay, you are not losing the data. So you have the local copy, everyone has their local copy, and it's very easy to restore. Okay. Okay, let's move on to the next slide. Any questions on centralized and distributed?
Yes, I do have one question. As you said, in the distributed version control system, we do have all the repositories on our server computer, and then
Yeah.
the same
Not
replica.
not not all the repositories, whatever the
All
repository you are
yes,
working on. Yeah.
yes, that's what. And you said that we have the same repositories on our computer A and computer B and so on.
Hmm.
So, like if I clone some particular branch, uh,
Hmm.
if I clone the developed
Let's
branch,
okay. I think we're not discussed about branching. You may be moving towards merge conflict. So let's
okay,
move.
yeah,
Let's
sure,
wait there.
sure,
Okay.
sure.
So so whatever we discussed so far on centralized version control system and distributed control system, whatever we discussed, anything you didn't understand and any questions here? No? Okay. Let's move to the next slide. So I think this is more about the Git snapshot. It's basically, it talks about specific versions of the file. So when we talk about SVN, like every file will be having specific versions. And the difference between Git is like Git will be, it's common. It's basically, it talks about the repo, not about the file. So different, like what happens in each version of the repo. Okay. Uh, how do you create a Git repository? So this is the command. Let me see if it's working. Uh, we can do a practical in parallel, or do you want me to go ahead with slides and then we'll work on practical?
These are some small commands we can use in practical as well.
Yes, yes. Do you want me to go with the practical now, or we'll do it later? Okay, let's do in parallel, so that would be useful. Okay,
Yes.
okay. So
Yes.
okay, so what is a repository basically? A repository is kind of container or a database where you can store your files. Okay, so that version control system database. So how do you create? So there are two ways of creating a repository. One is like create a repository into a remote server and clone it and push your changes, or you create a repository in your local, make all changes local, and push it to the remote server. Okay, so like git init is the command to initialize your repository, Git add is to add the files into that particular repository. Git commit is to, commit commit the changes to that repository. Well, we'll understand it better when we do practicals. Okay. And
Right.
okay, Git clone is like what is Git clone? It's basically as good as in SVN we are checking out the file. So Git clone is basically copying all the repository files into your local so that you can work on the local copy. Okay. So how it works is like you initialize your Git repository. So you create a folder, you initialize that folder with Git. Okay. And then you start working on your script or code or whatever you want to do. Once you're done with your code or once that file is completed, you have to add that file to the repository. So to add that file to the repository, this is the command you have to use, git add file name. So what it will do is like it will add to the repository. So there, I'll talk about like different, directory structure or tree structure of Git. Then you'll understand like what is add do and what is commit do. And once you're added that file to the repository, it's basically not pushed to the repository. It just tells you like what you want to add to the repository. And git commit is basically tells about like about the author or about whomsoever is doing the changes and what you want to commit, basically what you want to push to the repository. And once you are done with this, you can push all those changes to the repository into your local. That is one. And if you have a remote repository, so you have to specify like the branch name of remote, like URL and branch name. Okay. So a git clone is the command to clone the particular repository what you have created on, for example, in Git Bash. Uh, sorry, not Git Bash, GitHub. So we'll talk about the workflow and then we'll start doing your practicals. Okay. So workflow, like there are three workflows for your Git. Okay. So one of one of the very first one is your working directory. So for example, you created a folder, initialized it, and then you start working on it. So that is your current state where you are currently working. Okay. So when you execute git add, it moves your file to the next stage, that is your index or staging location. And when you do a commit, you move to the head, that is the third area, head of that particular commit or the changes you have done. Now if you have forgot to do something or miss something, you can go back to the previous unstaging location. So you do a git reset, you will come back to working directory, make the changes, add it again and commit it again and then push it. Are we clear?
Yep.
Okay. We'll see it. We'll do it practically. Then we'll understand. So this is the Git Bash tool. It's kind of client. Okay. So I was doing something here. So we'll do a some demo here where like we'll try to, what we're going to do is we'll create a Git repository. Then we'll work on, like we'll try to understand what is that stage, what is that head, what is the working directory. So I'll create some directory, for example. So demo git. So it's an empty directory. So what is the command we use for initializing the Git repository?
Git init.
So what it says, it has initialized the empty Git repository, right? Okay. Now we'll start working on like what. So now I'm in by default. What is the branch it created?
Master.
Master branch. Now we'll start. So this is the directory. That means like this is my working directory. I'm working here. So we'll start working, creating some file. Say demo1.txt. Okay. So now this is my working directory. To check the status, we can see like this git status. So what it's saying is like this is the unstaged file. So this is currently in your working directory. Okay. So remember this one, which we talked about, working directory,
Right.
then add will move to stage and then commit will move to head. Okay. So if I say git add demo1.txt and then we'll check the git status, what it says.
Typo.
Okay. So this is stage and ready to commit. Do you see the difference?
Yep.
Okay. Now, what is the next stage? If I have to move it to head, it's a head is basically head is the pointer which points to the current, where the current status of your repository. So if I say git commit -m, m is for message. What
Yep.
message you want to give, right? Testing a demo, right?
Yep.
So there's nothing to commit now. There's nothing in the stage location. We have committed everything,
Right.
right? Any questions so far? We're clear?
Does this, moving the file to staging and then moving it to the other
Mm.
thing, is it being shown to some other command also?
Uh, which command? Sorry.
Um, I mean, Git log is there. So in log file, what does it maintain? What logging it's maintaining?
It tells about all the commits you have done so far. So everything you have worked on this particular uh, repository. So it will tell about everything, no, whatever you did.
Okay.
It tells about like which commit you have done, who done the commit.
Okay. Gotcha.
Okay. So that is one of the thing I believe we'll talk about, like now what different commands we'll use. Git log. Okay. We'll move there. Okay. So we are ready to commit, and once this has been committed, so we are ready to push. So so this is into your local. Okay. Now we have to push it to that central Git repository server, the distributed version control system. So one of them, which we talked about, is GitHub, right?
GitHub. Yep.
Another example, uh, hardly like I'm not seen in any enterprises where we use GitHub, but mostly like it is mostly open source and all the freelancers or some of the companies may be working on GitHub, but mostly it is Bitbucket which is widely used in the enterprises. Okay, let's
Okay.
move on to GitHub. So you have to
Create
create,
account.
yeah, create account, create your own login and everything. Once you're logged in, you can, start creating repositories. So now we have to push our changes. So we call it as demo git. Okay. You can make it public, so it will be open to everyone, or you can make it private, so that it's very specific to the what whomsoever you give the permission. So I'll create a repository. So okay. So I'm already connected to this one basically. Okay. So let's move on to the slide. So we are clear till here, right? Then we'll talk about different commands and then we'll do our changes. Push it back. Okay.
So for public-private repositories, do we need to pay some amount to GitHub, or it's free?
Uh, Frankly speaking, like I am not a very good user of GitHub, so I'm more onto Bitbucket. But
Mhm.
uh,
Actually, there are limitations on the private repositories. I think you can have 5 private repositories, and if you are going beyond, then you have to pay, and you can have unlimited number of public
public.
repositories.
Okay.
Okay, we talk. So I think we talked about Git status, right? Uh, Git diff actually it is tells about if you're working like two-person working on the same file and what has been changed. So that's the difference we want to find it out. Git diff cached like it talks about the changes in your staging area. So uh, let's talk about Git diff first. So so if I say git diff, it will say like in this file what has been changed. So this was the previous state, previous location, previous state. This is the current state. What has been added is this testing demo. Okay, so that talks about your unstaging area. Okay, this is your unstaging area. So if I say git add and it will say git status. Refer it again. Sorry, my bad. So this will talk about your staging area differences.
So that plus shows it's in committed area.
No, it's in staging area.
I'm in staging area. Yep.
Yeah, yeah. So hyphen cached is the command we'll use to check the differences, what's been changed in the staging area. And if you don't specify cached, it will tell the differences in your unstaging area. Okay, then we'll do the commit again. Sorry. So when you say git log, you'll get all the information in your local directory about all the versions of the changes you have done. So this is the first version, right? So this is the commit ID which you have done. And this is the second version of that particular change.
Sorry to interrupt here, but what is the difference between a staging and unstaging area?
So yeah, so whatever we talked about this one, right? Working directory. So working directory is nothing, your unstaging area. Unstaging means what you are currently working on, or you have to you want to work on. So you have edited the file, you are not completed the changes, and then your shift is over. Tomorrow you'll come again and start editing. So once you complete and you are ready, like you have validated all the changes are done, so you move to the next stage. So you are ready to push your changes to the repository. So you move to the next stage is your staging area. Then you do a commit and push the changes.
Got it. Thank you.
Okay. So I think we created this one. So now we have done all these changes, right? Now we want to push our existing repository, which we have created. So we already initialized the repository here. We did all those changes, tested. Now we want to push it to the remote server. So you say git remote add, and what is the origin? So this is the particular origin of your remote server. So we'll try this one. Okay, and we'll do. So U is for your upstream, where you want to push the changes. Okay, so it's been pushed. So let's see. So we got the file. Yeah, the file we done it, right? And how many branches it has? It's just one branch. Must. Okay. So any questions so far?
It is common saying here. So what is the when we using the remote git remote and push when we want to push the code over in the repository, we are normally using the git push, and when we require to use the remote git remote, and what is different between this?
So basically remote is what you want to add it to the remote location, remote server. Okay.
Mm-hmm.
So
Mm-hmm.
when you have cloned the repo into your local, so for example, you not created the repository into your
Mm-hmm.
local and you have cloned the changes from a remote server, then
Mm-hmm.
you already know like where the server is, right? You have cloned
Yeah.
from that server, you have cloned all those repositories files into your local. So the communication is already established between your remote and local, right?
Right.
Where
Yes.
you need to specify remote when you're working locally and initialize the repository into your local. The communication has been not established yet between your local and your remote server. So to
Okay.
do that, like you do give a location, basically you add a remote server URL and the repository and push your changes from your local repository to the remote server.
So you mean sometimes we haven't git clone the repository. We just created repository in our local, and then
Yes.
again, then we want to push in our remote location. Before that, we need to do. establish the connection, right? Okay,
Yes,
that's
yes,
fine.
yes.
Oh,
It's
thanks.
basically like, and even for that, it's not like, you created the repository into your local and the remote server will understand by itself and it will create the repository by itself. It will not happen like that. So you have to, so if you remember, I created the demo Git repository, right?
Mm.
So now demo Git repository is created. So I need to map my local repository to remote repository and push the changes. That's it.
No, got it.
Okay.
Yeah.
Okay. Any other questions? We'll work on branching and see like why do we need branching? Okay. I think that's these are the two important parts where you should be understanding when we run the commands. Most of the people would be doing it like they must be using Git. Okay. But you should understand when I execute the command what's happening in background. So now we all are clear like what is a working directory. If I'm not doing git add, what happens? When I do git add, what will happen? And when I do git commit, what will happen? Okay. I think pushing changes we already discussed about, right? So if it is like the connection, you already cloned it, okay, and you have it in local or you already established the connection, you just have to use git push origin master. By default, the origin is master. You don't have to specify every now and then. But when the connection is already there, you just use git push origin master. When it is into your, when you not clone an existing repository and you created, initiated a repository into your local, then you give git remote add origin and the server details. Okay, I think that's what Kuman was asking. Okay.
Yeah.
Okay, branching. So why do we need branching? Branching is basically when multiple people want to work on different features. I'll put on mute for some time. I'm having a bad throat. So you have a repository created. Okay. Now you want like multiple people in your team, working on that on the same thing. So what you do is like you check out your code. Sorry, there's a background noise. So you check out your code. Basically, like the person A has cloned the repository and person B also cloned the repository. Both are working on the same branch. So there are chances where the conflicts may happen. Okay. So for example, person A would be working on one file and person B also working on the same file. So like person A has made some changes and push the changes to the remote server, but person B has not completed its changes. So when it tries to push, what error it will get? Like the remote server says, like I have a latest version of this file and your file is old. Okay, so there is some conflicts which you have to resolve. So that's nothing, that is your merge conflict. We'll discuss more in detail about merge conflict. We'll try to understand. So this is basically like everyone is working on the same branch and you can understand how many merge conflicts can happen. So what is the best way to do it? First of all, you distribute the work within the team. So what you have to do, like you assign one particular feature development to one of your team member, another feature development to another team member. So what you can do, you can create two different branches, one for feature X and one for feature Y. Now they are working separately on their branches, different branches. Okay, there are no conflicts. Okay, so they start, working on the branches, start, adding the files, doing the commits, pushing the changes to their branches. Okay, so mostly in wider environments, we use like this feature-based development. This is known as your feature-based development. Okay, so how it works is when we talked about continuous integration, so this is how the continuous integration works. So you have a master branch. Okay, so let me try to explain it on a board. Shall we give a try if it works? Okay, so you have your repository here. Okay, and you have your master branch. Okay, and what we're saying is we create feature 1, we create feature 2. Okay, and you have 2 people working. So he checked out feature 1, he checked out feature 2. They start, doing their changes locally, and once they are done with their changes locally, they start pushing to their specific branches. Okay, as many as commits. So there are no conflicts as of now. Same here. Okay, so what, like this is what the feature based development. So this is your master branch. Okay, so you will be having this, your master branch. Okay, and you take out different branches out of it. Okay, feature 1, feature 2. So once your, say for example, feature 1 changes are completed. So for example, you have a banking system app where you have login, you have registration. Okay, but registration was basic registration, OTP was not there. So you started working on this OTP feature. As of now, your live system is running with login registration, the generic one. Now the so your team started working on the OTP feature. So your OTP feature is completed, and so your master code is deployed in live. Okay. So now you're taking the branch out of the live master and you started working on this OTP feature. Your feature is completed. What you will do is now you merge this branch to master. So you have a new master now. So in some organization they work on master, or in some they do release based uh, deliveries. So you say like release 1, 2, 3, 4, 5. So they will push those feature 1 changes to release. Okay, and then this release will go to live. So here we're talking about, like in some organization they follow this master 1 where they push the master branch code changes to live. Now feature F1, the feature 1 branch has been merged into master, so it is ready for the testing. So the moment it has been done, then it will follow the cycle. So if you have a new master branch, then it will go for your integration test. Then it will go for your regular performance test. Then it will go for UAT. Then it go for your non-live testing and the live. So this is your feature-based development. Now, what if, like I'm also working on different feature. Okay, I'm going to talk about merge conflicts now. Okay, let's move on to that slide and then we'll understand. So any questions on branch as of now?
Actually, I want to add something on branching, how we are processing the branching strategy we are doing. Okay, so normally what happened, what you have mentioned that developers, they are working mostly on feature branch, and like suppose we have 2-3 developers, so they are working on their own feature branch, and once they done their work, they can. So we have a branching strategy, like we have dev branch and release branch and then master branch. So whatever they have developed their code, they just push the code into dev once. So all combination, all coding in dev branch, and then once dev is done, then we are it's merge into release branch, and then in release branch only we are doing pen testing, like performance testing, this testing. Once that testing is done, then we just deploy that release branch code into cert, cert and production. And once they approve it's working fine, then we are merging that code in a master branch. So master branch always we have live code, is a production code. Uh, master branch, master branch code we are merging once is approved from the QA and UAT team. So we are not directly merging release branch to master branch, and we are not deploying production code from the master branch. We are deploying code from the release branch, and once is that this is fine, then we are merging code release branch to master branch. Yeah, that's it.
Okay. Yeah. Thanks. I think we discussed about the same thing. So
Yeah.
what? Yeah. Kuman was trying to say is like in some organizations, people directly work on master branch, and in some organization, people work on release branch. Okay. So it's basic. Used what we talked about here, right? Release branches. So
Uh,
you have your yeah.
Just I wanted to add something. Like I think many people of here are they are newbies. So I think it may create some confusion. Like just keep it very generic for them, like the branching
Yeah.
strategy. If we are
Yes.
talking about organization across the organizations, then it might create confusion for them, and
Yeah.
maybe they
No.
lost it between. Yeah.
No problem. So yeah. So uh, even this is generic and it has to be remembered and learned. So there are different branching strategies being used by different organization. So one which we talked about is like when I say feature based development, it's basically you can give whatever the name you want to give to the branch. You can give dev, you can give feature one dev, whatever the branch name you want to give. So dev usually it's a common methodology being used for development. That's why they refer it as dev. So you work on that particular feature branch. So all your teams start working on checking out on your branch, pushing the changes into the branch. Once your feature is complete, you merge those changes to your master branch. So now you are ready for the deployment. So but before going uh, for the deployment, you have to do all the testing. You have to do integration testing. You have to do performance testing. You have to do user acceptance testing. These are the different stages of testing before you make your code to go live. Okay. The other branching strategy is like, what if like some bugs are there, you know, and in your master branch and it stopped working, then it is very hard to revert the changes from the master. So you have to go back to the version, find out like what the changes has been done. You have to rebuild your code. Or if you have already the previous version of the artifact, it's very easy and go and redeploy that the previous version. The only difference here is it's very easy to handle when you follow this release branch strategy, where what you do is like you deploy a release branch. So earlier what we are doing, we are merging the changes from feature branch to the master branch. Now there will be one more branch in between, which will be release branch. So you mostly working on that release branch. So consider this release branch as a master branch, what we had understood in the previous session. So now we start doing all these testing on release branch. So you take the release branch, you do the testing, go for all the stages and make it live and monitor it for some time. So if you don't have any bugs reported within a week or so, you and it has been approved by all stakeholders, make those changes and push to your master branch. So your master branch is basically a master of all your codes. And it is very easy for you to, like, because you use different release branches, it's very easy for you to understand, like, this particular release has caused the issue, go to the previous release, this particular feature can be disabled, and use the previous release and deploy it. Okay, we'll see like how it works now, how the branching works, and then we'll understand like what is a merge conflict, and then we'll close the session. Okay. So to create a branch, what is the command we have to use? You have to use git checkout -b and the branch name. And if you have to like switch between the branches, you have to give git checkout and the branch name. So if you have 3 branches, you give just git checkout and the branch names. And the way to delete the branch is git branch -d. It will delete the branch. Okay, let's test this. So we have a master branch, right? When we tested, I will create a branch now. So git checkout -b and the branch name. So we'll say feature underscore x. So this is the name of the new branch. Okay. Can you see? You can notice it now. Okay. Now I can start working on this particular directory, working directory on this branch. So I'm a new developer working on a different branch now. So I'll say search. I will do git status. So this is the unstaging location. Now we'll move it to the staging location. Okay. Now git commit. And then what we'll do? We'll push the branch. So what it is? Git push origin. By default, it is master. Now we are not in master. We have to specify the branch name. So what you say? Git push branch. And what is the branch we have created? Feature X. Did I do any mistake? Sorry. My bad. Not branch, it's origin. Right? Clear? We can go and check if the branch is created. Okay. So we can see there are 2 branches, master and feature. Okay. Why we got demo 1 as well? in this branch? Any
Uh,
answers?
I think it was checked out from master, right?
Yeah, it always gets checked out from master.
Yeah,
So
which
when
is
we
why it's
talk,
highly.
yeah. So when we are talking about branching strategies, right? When we say checkout is basically it cuts that particular branch from the current location of master and then create a new branch. Okay, here. Now we'll run this. I think we talked about merge conflicts. Uh, I'll leave it with you guys. So we'll talk about merge conflicts, and then we'll see like what are the conflicts, how it works, and then it kind of homework for you. So you give it try yourself and try to resolve, and just let me know if you face any issues. So like how to resolve, what to resolve. So what is merge conflict, right? So merge conflict is basically when two person working on the same file. So we talked about a scenario, right, where two person working on the same file, and someone has already pushed the changes, and you're still working on local. Okay, so when you try to push the changes into the remote directory, you see if you'll get this error, kind of merge conflict. Okay, so you'll be getting this kind of error, like there is a merge conflict and you have to resolve that merge conflict. So basically this arrow, the upper arrow, like this less than symbol, is a headline, is content that exists between your current master branch and, so this is basically the divider, the center line. So this less than symbol shows your current branch information, and after the center line to the greater than symbol, it shows the remote branch difference. So there are two ways of resolving the conflicts. You can let go your changes and consume the changes in the remote, or you can omit the remote branch changes and keep yours, or the third one is keep both the changes. Okay, this is the way you should be working on the conflicts. So in, like, this is what we're talking about when two people are working, right? But in organization, multiple developers work together on different branches, right? And when they try to push that, want to merge those branches to the master, they may be encountering lots of conflicts. So what is the way to avoid that? So the best way to avoid that, whenever you are working on a branch, you always, when you come in the morning, you always take the latest update from the remote repository and resolve the conflict. Okay. So how to get the latest changes from the remote? You have to use git pull. So when you run git pull, it pulls all the changes for remote repository. And if there are any changes in your local, and if there is a mismatch, there is a merge conflict, you resolve it in your local. What if, like, you start, because these feature development may takes time. So someone follow different, sprints, like could be 4 weeks, could be 2 weeks. So after 4 weeks, you have done all your changes in your local and you are ready to merge your branch. The moment you merge, because there are other people also working and taken out the branches from the master, and they already pushed their changes. And the time after 1 month, when you do a try to push your changes and try to merge, you'll see thousands of differences, thousands of conflicts, and it is very hard for you to resolve, and it will very time consuming. So the best approach and the recommended approach for you is always take the latest changes from your remote repository daily whenever you work. So you take the latest, tomorrow morning you come, take the latest changes. If there are any merge conflicts, resolve and start working on it. So end of the day, when your sprint is complete and your feature is ready to merge, you'll be having very less conflicts. Okay. Okay. Any other questions? slide now. Any other questions from anyone? I'll consider silence as no. And everyone is a master in Git now. Okay. Okay then. If there are no questions, yeah, if there are no questions, then I think we are good to close the call. Thanks everyone for this session, joining this session and contributing to this session. And in the subsequent sessions, I'll share the details of what would be the next session, what would be the topic. If there are any suggestions from anyone, they want to, learn about a specific topic, and if I get, response from 3 or 4 people and they're interested on the same topic, I'll consider that topic and we'll start the presentation next week. Okay? Yes,
Yeah,
no?
sure.
Or everyone slept? Okay, guys. Thanks
Okay.
everyone for joining. Yeah.
Okay. Thank you.
Yeah.
Bye
Yeah.
bye.
Okay,
Bye
thanks.
bye. Thanks.